Hello children, today I am back again, your Vanashri ma'am, with another chapter, Circles, Part 1. A small portion of the circles has been already taught to you in Standard 9. Though the theorems that you have learnt in Standard 9 will not be asked for proof in Standard 10, but those theorems many a times you will have to use while solving some questions. So it is better we revise once again whatever we have learnt in Standard 9. So in Standard 9, you have learnt the basics of circles, that is, for example, this is a circle, this is called the center of the circle. Now the line joining any 2 points on the circle and passing through the center of the circle, say A, B are 2 points, the line joining 2 points on the circle and passing through the center is called diameter. So here AOB is the diameter. Okay. Then radius, you have learnt. Radius is the line joining the center of the circle to a point on the circle. So here OC is the radius. Okay. Radius is usually denoted by small r, diameter is usually denoted by small d. Now the diameter is twice the radius. Diameter is equal to twice the radius. Then you have also learnt about chord. Chord is a line joining any 2 points on the circle. So say CD. So here CD is the chord. Okay. Diameter is also a chord. In fact, diameter is the longest chord which passes through the center. Okay. So the diameter is a longest chord, because it is also a chord because it is a line joining 2 points on the circumference of the circle. Only difference is diameter passing through the center of the circle also. Okay. Now these are the basics that you have learned, and then you have learned certain theorems that you have learned in 9th. So I am still continuing only with the theorems that you have learned in 9th. Okay. So the theorems learned in 9th, one theorem that you learned, a straight line drawn from the center of the circle a straight line drawn from the center of the circle to bisect a chord is perpendicular to the chord. Okay. So it means if there is a circle with center O and there is a chord, say AB. Okay. Now if a straight line is drawn from the center of the circle to bisect a chord, so to bisect a chord means joining the midpoint, say M. If M is the midpoint of AB, if a straight line is drawn joining the center and the joining the center and the midpoint of the chord AB, then as per this theorem, it implies that OM will be perpendicular to the chord. Okay, that line, straight line which is drawn from the center bisecting the chord AB, then OM is, this implies M is the midpoint, that is why AM is equal to BM. In that case, OM is perpendicular to AB. Okay. Now the second theorem that you learnt in 9th states the converse of this. The perpendicular to a chord from the center of the circle, bisects the chord. Which implies if a circle is there, O is the center of the circle, a perpendicular is drawn to the chord AB. So a chord is there AB. Okay. Now a perpendicular is drawn, say OP is drawn perpendicular to AB. In such a case, OP will be bisecting the chord AB. So in that case, it implies OP bisects chord AB, implies AP is equal to BP. Okay, if it is perpendicular, then automatically it will bisect the chord. Okay, then you have learned that the next theorem that you have learned is equal chords of a circle are equidistant from the center. That means, suppose in a circle there are two equal chords, say AB and CD, and these two chords are equal. Okay, then they will be equidistant from the center. Means if this is the center O, equidistant means the perpendicular distance are same. So the perpendicular distance from the center, what is the perpendicular distance? Say OM is the perpendicular distance of AB, chord AB from center O. Similarly, if you draw a perpendicular like this ON on CD, chord CD from the center O, then according to this theorem, OM will be equal to ON. That means if AB is equal to CD, implies OM is equal to ON. Okay. Now, the next theorem, converse of this, you have learnt in 9th only. Equidistant chords are equal. Equidistant equidistant chords. From where equidistant? Equidistant chords from the center are equal. Okay, that means if you have a circle like this and you have two chords AB and CD and they are equidistant from the center. So if O is the distance, then they are equidistant means if OM is equal to ON, it implies that chord AB is equal to chord CD. Okay, here it was if chord AB is equal to chord CD, then OM is equal to ON, and now if OM is equal to ON, then chord AB is equal to chord CD. Okay, so these are called converse theorems, right? So these all you learnt in standard 9. Now in standard 10, before we proceed further to learn theorems of standard 10, you must learn certain basic points. So now your standard 10 portion begins. Okay, now here you must know what is an arc. An arc is a part of the circumference of the circle. So if this is a circle, then this part, say PQ, is a arc. PQ is also an arc and this major part is also another arc. Okay, say if you name this as R, PRQ is also an arc. Okay, so arc is a part of the circumference of the circle. Okay, so now if you join PQ, it becomes a chord, isn't it? So this is a chord. So this chord divides the circle into two arcs. One is this PQ and the other one is PRQ. Okay, so now PQ is called minor arc. PQ is called minor arc and PRQ is called major arc. Okay, now, or you can say the arc which is less than the semicircle is called minor arc and the arc which is more than the semicircle is called major arc. Anyway, these definitions nobody will ask you, you must know the meaning. Okay, now the chord also divides the circle into two segments, like the area, the space bounded between the major arc and the chord is called major segment. So for example, suppose this is an chord AB. Okay, so this chord is dividing this circle into two segments, and this is called the minor segment, that is the space enclosed is the part of the circle enclosed bound by between the chord and the arc. Okay, so minor segment is the part of the circle enclosed between the minor arc and the chord, and this is the major segment, the circle, part of the circle The part of the circle bounded between the chord and the major arc is called major segment. Okay. Now with this background, let us start the theorems that are there in standard 10. Now the proofs of these theorems of late, or rather from 2015, have started asking in the boards. Earlier they never used to ask, but now they are also asking the proof of any one of the theorems in section B. And the other questions where you are applying the theorems and doing, they come in both section A as well as section B. And this chapter has maximum weightage. So let us learn. Now the first theorem in standard 10, the numbering of the theorem is not important. Okay. So first theorem in standard 10 you will be learning, very important theorem. This is standard 10 we are starting. So in standard 10, the first, these theorems are never referred with their numbers. You have to write the entire statement of the theorem whenever you have to use in square brackets on the right side. Now the first theorem in standard 10 you will be learning is that the angle which an arc of a circle subtends at the center is double that which it subtends at any point on the remaining part of the circumference. Okay, remaining part of the circumference. Using this phrase, on the remaining part of the circumference, is compulsory. Okay, the angle, now let me explain to you. The angle which an arc of a circle subtends at the center means what? Suppose there is a circle, okay, there is a circle with center O. Okay, now the angle which an arc of a circle, so there must be an arc, say AB is the arc. Okay, so the angle which an arc of a circle subtends at the center, so the arc AB, say, subtends angle AOB at the center, angle AOB at the center. AOB is the angle made by the arc at the center. So according to this theorem, this will be double the angle that which it means same arc makes at any point on the remaining part of the circle. Remaining part means, suppose if you name this as here C, so the remaining part of the circle is ACB, not AB included. So the remaining part of the circle, if it makes any angle, say here, Suppose it makes an angle at the same arc, makes an angle at D in the remaining part of the circle. Okay. So, according to this theorem, angle AOB will be double the angle made by it at D, that is in the remaining part of the circle. Okay. Is that clear? Now, remaining part I told you very important. Now, for example, the same thing, see ACB is also the major arc, AB is the minor arc, whereas ACB or ADCB is the major arc. Now, the major arc also can subtend an angle, okay? So, where will it support, where will it make? In that case, suppose this is the center O. If this is the arc AB, minor arc, then ACB is the major arc. Now, major arc we can subtend an angle. This major arc will subtend an angle at O. So, this reflex angle is the arc made by the major arc OCB at the center. This reflex angle, isn't it? Now, this reflex angle will be double the angle made by the major arc ACB in the remaining part. Now, for this major arc, the remaining part is the arc AB. Now, in this part, if it makes an angle, say ADB, then reflex angle AOB will be double the angle ADB. Understood? So, in this case, angle AOB is double the angle ADB. Okay. And in this case, reflex angle AOB will be equal to double the angle ADB. Okay. Is that clear? Now we will prove it. Okay. So we will prove taking this example. Automatically the same thing can be applied and proved. Okay. So now we will consider this picture. Arc AB. Okay. So angle AOB is the angle made by the arc AB at the center, and say angle ACB is the angle made by the same arc AB in the remaining part of the circle. So what we have to prove? What we have to prove is angle AOB is equal to prove angle AOB is equal to twice angle ACB. Okay, this is what we have to prove. Angle AOB is equal to twice angle ACB. Now, in order to prove that, we have to do some construction. What is the construction? We have joined CO and produce it to a point D. That is, we join CO and produce it up to a point D. Okay, that is the construction we need to do. Now proof. Construction, first you write down join CO and produce it to point D. Okay. Now the proof. The proof. Now consider triangle. Consider triangle A C. A O C. Consider triangle A O C. Okay. A O C. This is the triangle you have to consider. Now in triangle AOC you have OA is equal to C. OA is equal to OC. They are the radii of the same circle, isn't it? So in triangle AOC, OA 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 is equal to OA is this one and OC is this. Okay, the dotted one. Okay, OA is equal to OC. The reason should be always written in square brackets. They are radii of the same circle. Radii is the plural of radius. Radii of the same circle. Okay. Now, angle OAC is equal to angle OCA because this is an isosceles triangle, isn't it? OA is equal to OC. So, the angles opposite to equal side, that is angle OAC is equal to angle OCA, right? So, angle OAC, you can number the points and it will be easy. Then angle OAC is equal to angle OCA. What is the reason? Angles opposite to equal sides. Angles opposite to equal sides in an isosceles triangle are equal. Okay, angles opposite to equal sides are equal, so that is why these two angles are equal. Okay, now you have learnt in your smaller classes the exterior angle is always equal to the sum of the interior opposite angles. So now in this triangle the exterior angle is this one, that is this angle is the exterior angle, that is angle AOD. This is the exterior angle. This is equal to sum of the interior opposite angles, isn't it? So angle AOD, exterior angle, exterior angle AOD exterior angle AOD is equal to angle, see these two interior opposite angles, that is angle, these two are the interior opposite angles, angle OAC plus angle OCA. But from 2 we know that these two are equal. So we can write this as implies angle AOD is equal to angle OCA plus angle OCA. This is from point number 2. While in point number 2 we have proved OAC is equal to OCA. So in place of OAC we are writing OCA. Right? So that means this implies angle AOD is equal to twice angle OCA. Right? It follows from this. Now similarly in triangle BOC, if you take this BOC, same way we can prove that exterior angle BOD is equal to twice angle BCO, right? Similarly, we can prove in triangle BOC, exterior angle BOD is equal to twice angle BCO or OCB, whatever you call. Since we have called this as OCA, we will call this OCB. Okay, OCB. We can prove similar manner. So now, if you consider 4 and that is 5 and 6, so what happens? Angle AOD plus angle BOD, exterior angle BOD and exterior angle AOD together, if you add, you will get angle AOB, isn't it? So adding 5 and 6, we get angle AOD plus angle BOD is equal to twice angle OCA plus twice angle OCB. In other words, this implies angle AOD plus angle BOD together makes angle AOB is equal to twice angle OCA, we are taking out 2 common, angle OCB. So angle OCA plus OCB, let us see the picture. Angle OCA plus angle OCB is nothing but angle ACB. Do you agree? So this implies angle AOB is equal to twice angle ACB, which proves the theorem. Okay, hence proved. Is it clear? Very important theorem and very widely used theorem. So practice this, write the proof on your own several times without seeing. First go through it, then you write on your own, because nowadays they have started asking proof of a theorem, any one theorem for 4 marks. Okay, so this is the, now let me stop here so that you can, we will continue again the next theorem in the next class.